Hello everyone. Today I will present our feedback control project, which focuses on implementing a closed-loop control system for a JK370 DC motor with an encoder using a Raspberry Pi 3B Plus as the main controller. Let's begin with the system overview. As shown in our block diagram, the core of our design is the L298N motor driver, which controls the direction and speed of the JK370 motor. It receives PWM and logic signals from the Raspberry Pi and outputs the necessary voltage to the motor. In this case, plus 12 volts and minus 12 volts supplied by a 12-volt battery. The encoder baked into the JK370 motor provides real-time feedback on the motor speed and position. This feedback signal is sent to the Raspberry Pi, allowing the system to measure the motor's performance and make corrections automatically. The Raspberry Pi is powered by the buck DC to DC converter, which steps down the 12-volt battery supplying to stable plus 5 volts and minus 5 volts for the electronics. The Pi also outputs a 3x3 volt reference for the sensors, including a gyroscope, which we plan to use for additional orientation data in future work. All components share a common ground, which ensures signal consistency and stable communications between modules. Now let's talk about the control system. We implement a PID feedback controller on the Raspberry Pi to regulate motor speed. The encoder continuously samples the corresponding motor rotation. The Pi calculates the actual speed from these passes and compares with the target speed. Based on the error, the PID controller adjusts the PWM duty cycle sent to the L298N. This creates a closed-loop system, meaning the motor automatically corrects itself whenever there is a disturbance such as load changes or friction changes. During testing, we observed that the controller successfully minimized steady-state error and kept the motor stable even under small external disturbances. By tuning the proportional, integral, and derivative gains, we achieved smooth acceleration and accurate speed tracking. For safety, the system caps power if the encoder feedback is lost or if the battery voltage drops below a certain limit. In summary, our feedback control project demonstrates how the Raspberry Pi combined with JK370 motor encoder and L298N driver can create an effective and reliable closed-loop control system. It can be future expanded to include position control or multi-sensor fusion with gyro for more advanced robotic applications. Thank you for listening.